Okay, let's do the example 6. Find the derivative of the function 2x, that is f of x is equal to 2x squared plus 3x minus 5 at x is equal to minus 1. Also prove that f dash of 0 plus 3 f dash of minus 1 is equal to 0. Okay, so let's find the derivative of the function at x is equal to minus 1. So as you know, the first principle derivative formula, that is f dash of x, is equal to limit h tends to 0 f of x plus h minus f of x upon h. Okay, this is the formula. Now this is f of x, so f dash of x will be so let's put the function here. So it will be limit h tends to 0. Now all the x variables will be added with h. Okay, x plus h, so you get it 2, this is x square, so it become x plus h whole square. Okay, plus 3x will become 3x plus h. Okay, minus 5, and now this is completed. Now minus function as it is. Okay, so it become 2x square plus 3x minus 5. Okay, upon h. Now this is f dash of x. Now f dash of x at x is equal to minus 1, so this will be, we'll take x is equal to minus 1. F dash of minus 1 is equal to limit h tends to 0 to, now let all the x be replaced with minus 1. So minus 1 plus h whole square plus 3 into minus 1 plus h minus 5, now minus 2 minus 1 whole square plus 3 minus 1 minus 5. Okay, upon h, which is equal to limit h tends to 0. Now this is in the form a plus b whole square, a minus b whole square. Okay, now 2, let this be a and this be b, a and b. Okay, so it's square plus 1 square minus 2 h. Okay, now this will become minus 3 plus 3h minus 5. Now this will become 1 square will become 1, so 2, that will become minus 2. Now this will become minus 3, minus into minus will become plus 3, and minus into minus will become plus 5. Okay, upon h. Now limit h tends to 0, let's multiply 2 inside. Okay, so 2h square plus 2 minus 4h minus 3 plus 3h minus 5 minus 2 plus 3 plus 5, so on upon h. Now you see 2 and positive 2 and negative 2, this will go. Negative 3 and positive 3, this will go. Negative 5 and positive 5, this will go. So the remaining are limit h tends to 0, 2h square minus 4h plus 3h. Okay, upon h. Now you see you have h's in the numerator in all these expressions. Let's take h common, so it will become limit h tends to 0, h common, so here you will get 2h minus 4 plus 3. Okay, upon h. Now this h and h get cancelled, so you will have limit h tends to 0, 2h minus 4 plus 3 will become minus 1. Okay, upon, no, not upon, that's it. Okay, now putting the value of h in the expression, you have 2 0 minus 1, which is equal to minus 1. Okay, 0 minus 1 is minus 1. Now this is f dash of minus 1, that is minus 1. Okay, f dash of minus 1 is minus 1. That is the derivative of the function at x is equal to minus 1. Okay, now here we have to prove that f dash of 0 plus 3 f dash of minus 1 is 0. Now we have already got f dash of minus 1. So we want 3 f dash of minus 1. Just multiply 3. Okay, multiplying 3 with this, 3 f dash of minus 1 is equal to 3 minus 1, which is equal to minus 3. Okay, now the second one is f dash of 0. F dash of 0. Now let's put 0 in this expression. Okay, that is 2 limit h tends to 0 to, now here 0, instead of x we put 0, 0 plus h whole square, okay, plus 3 0 plus h, plus 3 0 plus h, minus 5 minus 2 0 square, 2 0 square plus 3 0 minus 5, okay, upon h. Okay, so this will be limit h tends to 0 to 0 plus h is h square plus 0 plus h is h, so it will become 3h minus 5, 2 0 0 square 0, this will become 0, this also becomes 0, so you have minus 5, minus and minus will become plus 5, okay, upon h. Now this will get cancelled. You have limit h tends to 0 to h square minus 3h upon h. Now let's take h common, see, from this. So you have limit h tends to 0, h common, so 2h minus 3 upon h. Now this h and this h get cancelled. You have limit h tends to 0 to h minus 3. Now putting the value of h in the expression, you have 2 0 minus 3, which is equal to minus 3. Okay, now f dash of 0 is minus 3. Now they said prove that, we have to prove that f dash of 0 plus 3 f dash of minus 1 is equal to 0. Now we got f dash of 0 is minus 3, this is minus 3 plus 3 multiplied, sorry, this is not minus 3, this is plus 3, okay, this is plus 3h, plus 3, so this will be plus 3, this will be plus 3, okay, you have plus 3 here, okay, and now f dash of minus f of minus 1 is minus 1, so you have minus 1 here, this equals 0. Now 3 minus 3 minus 1, okay, minus 1 will become minus 3, it is equal to 0, okay, 0 is equal to 0. That's it, we have proved it. Okay, now we'll do this in the second method. This is the first principle method. Now we will do it in the second method. Okay, now we will do this using the second method, that is power rule method. So f of x is equal to 2x square plus 3x minus 5, okay, and x is equal to minus 1. Now in power rule method, okay, so let's take, we use normally the notation, or as you know, y is equal to f of x, okay, so instead of f of x we take y, okay, it can be f of x, it can be also be f of x, but for the notation it's better you take y is equal to 2x square plus 3x minus 5, okay, or it's okay, we will take no problem, we'll see. Okay, so dy by dx of x power n equal to n x raised to n minus 1 is the formula. Okay, so we'll have, now this is y is equal to 2x squared plus 3x minus 5, okay, so now the derivation of this dy by dx equal to dy dx of 2x square plus 3x minus 5, okay. Now by the theorem we can split, that is sum of two functions, okay, derivative of sum of two functions we can split the derivative to each expressions. Okay, so this can be written as d by dx of 2x square plus d by dx of 3x minus d by dx of minus 5. Okay, no, just 5. Okay, minus is here. D by dx of 5. Okay, now again, by the theorem of constant into function multiplied by function, the constant can be brought out. Okay, so you write it as 2 d by dx of x square plus here also 3 d by dx of x minus, now the derivative of constant is always 0. Okay, so this is 0. Let it be any constant, any number, it's 0. Now according to this formula, this can be written as 2 as it is x raised 2 as it is and multiplied 2 x raised to 2 minus 1. Okay, according to this the power will be multiplied, then x raised to n minus 1. Okay, plus 3, and the derivative of a variable with power 1 is always 1. Okay, so this is 1 and this one 0. Okay, now you have this one as 2 multiplied to 4 x raised to 2 minus 1 is 1, so 4x plus 3. So this is the derivative of the function. Okay, now the derivative function at x is equal to minus 1, so we'll write it as dy by dx dy by dx at x is equal to minus 1. This is how we denote it. Okay, so putting the value of x as minus 1, you get 4 minus 1 plus 3, which is equal to 4 minus 4 plus 3, which is equal to minus 1. Okay, now the same way, so now 3 multiplied by f of 1 will be 3 multiplied dy by dx at x is equal to minus 1 will be 3 into minus 1, which is equal to minus 3. Okay, and also again dy by dx at x is equal to, the next one is 0. Okay, x is equal to 0 will be the same expression, you have to put x is equal to 0, so 4 into 0 plus 3, 4 0 0 0 plus 3 is equal to 3. Now prove that f dash of 0, or you can write dy by dx at x is equal to 0 plus dy by dx 3 dy by dx at x is equal to minus 1. This will be at 0 it was 3 plus at x is equal to minus 1 is 3, that was minus 3, so 3 minus 3 plus minus 3 will be 0. Okay, that's it. This is how you solve this using the power rule method. Okay, that's it.